Okay, what I want to do today was calculate the value for digamma of minus 1 over 6. And we're going to be doing it the long way. The reason is I want to get some other values along the way, and I also want to get some other formulas along the way. So this is the justification. Okay, so to start with, what I want to do is use our multiplication formula here on this. What we'll do is we're going to make this value like the n in this formula. So we're going to say n equals 6. And then what I want to do is make z 1 over n, or z is going to be 1 over 6. And then I'm actually just going to rearrange it right from the beginning. So I'm going to multiply by n on both sides here. So then by doing that, we can cancel. This is going to cancel here, and I can multiply this in here. Then let's isolate this on one side, but I'm going to plug in, let's start plugging in the n values on this. No, actually I'm going to plug in the n and z values later, so we're just going to leave it as a formula. So we're going to go k equals 0 to n minus 1. Then on the other side, we're going to still have this n digamma nz. But actually, the way I want to do it in this formula, I want z to be 1 over n. So no matter what value of n we have, this is always going to be 1. So here we end up with digamma of 1 minus this part here, n ln n. But digamma of 1 is just minus the Euler-Mascheroni constant, so I'm just going to replace that here, minus the constant. Then next, I want to focus on this part here. We're saying we want z to be 1 over n, so I can actually get rid of z completely in this equation, replacing this with 1 over n. And then we have a common denominator, so we can put this together as k plus 1 over n. So doing that, now our sum is going to go just to n minus 2, because we're stripping out one term. So we start at 0. So then this is going to be the same thing here. But then for this term that we pulled out, this n minus 1 term, what we have is digamma n minus 1 plus 1 all over n. But notice, minus 1 plus 1, that's just 0. Now we have n over n. The whole thing's 1. So if the whole thing's 1, we know what this is. This is again going to be minus Euler-Mascheroni constant, and we've got all the other stuff on the right side. But then I can just add one copy of the constant on both sides of the equation. This cancels here. If I'm adding 1, we've got the same thing here and here. So just adding 1, I can write this as 1 minus n times Euler-Mascheroni constant. This goes away. Let's just do an index shift over here. If I subtract 1 here, I just need to add 1 here and here. But then what we have here is a pretty compact formula, because this is pretty easy to calculate. And then on the left side, as long as n isn't too big, this isn't bad. I mean, if this is, so in our case, we're saying what's going to happen is we're going to want n to be 6. So this expression over here is going to be like digamma 1 over 6, digamma 2 over 6, digamma 3 over 6. And the last term's n minus 1, so this is going to go digamma 5 over 6. So now that we have this, let me clean up the board and we'll continue from here. Okay, next let's go ahead and use this formula, but let's not start with n equal to 6. Let's see what happens when n equals 2 on this. So we're going to have the sum from k equals 1 to 1 now. So it's just going to be a single term where we're going to have digamma of k over 2. The nice thing about this is just one term, and it's just going to be digamma of 1/2. So it's going to get us this actual value real quick. So we're going to have 1 minus n, where n is 2, so this is going to be minus Euler-Mascheroni constant. Plug in 2 here, and we have minus 2 ln 2. And so that's going to give us a value for digamma of 1/2. Next, let's see what happens when we have n equals 3. So now the sum is going to be from k equals 1 to 2 now, digamma of just k over 3. On the right side, 1 minus n, so this is going to be minus 2. Euler-Mascheroni constant, plug in 3 ln 3. Now we're going to have two terms. We just need to plug in 1 and 2. So we have digamma of 1/3 plus digamma of 2/3 equals all this. Okay, now we'll look at our n equals 6 case. So what's going to happen now, we've got our sum going from 1 to 5 now. Digamma k over 6 on the left side. Then for our equation, 1 minus n, so we have minus 5. Euler-Mascheroni constant minus 6 ln 6. But now this left side's getting kind of complicated, so I'm going to actually write this out of order. So what I'm going to do is the first and last terms first. So we're going to have digamma 1/6 plus digamma 5/6. Then digamma 2 over 6 is digamma 1 over 3. Digamma 4 over 6 is digamma 2 over 3. I group it this way so I can use this over here. And then the middle term, digamma 3 over 6, is just digamma 1/2. And so this is all this right here, minus 5 times the constant minus 6 ln 6. But then I can isolate digamma 1/6 and digamma 5/6. And then let's just like subtract these and bring it on the other side because we have these values here. So if I subtract this, we're changing the sign on this, we get 2 times the constant plus 3 ln 3. Subtract this, change the sign here, we get plus the constant plus 2 ln 2, and then we have minus all this stuff. Here, adding up all the constants, 2 plus 1 is 3 minus 5, so we have minus 2 times the constant here. For ln 6, I can write this as ln 3 plus ln 2. So what's going to happen is we're going to have 3 ln 3's minus 6 ln 3 is going to be minus 3 ln 3. And then we're going to have 2 ln 2 minus 6 ln 2 is minus 4 ln 2. And this is going to be our value for digamma 1/6 plus digamma 5/6. But then here the question becomes, how do we isolate individual values? Like what is digamma 1/6? What is digamma 2/3? Well, for this we can use another formula. We'll use the reflection formula that tells us for digamma 1 minus c minus digamma of z, this is just pi cotangent pi z. So if we set z equal to 1/3, what's going to happen? We have digamma 2/3 minus digamma 1/3 is going to be pi cotangent pi over 3. But this value here is just going to be square root of 3 times pi. So what we can do with this equation and this equation, we've got two equations, two unknowns. If I add these two together, the digamma 1/3 cancels and we get 2 digamma 2/3 is going to be equal to this, square root of 3 pi plus all this. Divide by 2 on both sides, and now we've got our value for digamma 2/3. Next, what I can do is take this equation and subtract this one from it. That way the digamma 2/3 cancel out. What we're going to be left with is 2 digamma 1/3. We'll start with this over here, minus 2 times the constant 3 ln 3 minus this. Again, divide by 2. And now we've got our value for digamma 1/3. Okay, so next, getting closer to our goal. Back here, we want, let's say we want z to be 1/6. Then we get digamma 5/6 minus digamma 1/6 equals pi cotangent pi over 6. Actually, now I'm noticing my mistake from before. Cotangent pi over 3 is actually 1 over square root of 3. So I need to fix this here and bring the square root of 3 into the denominator on both these. And now here, cotangent pi over 6, that's square root of 3. So now this is square root of 3 times pi. Doing the same thing we did before, add this one to this one. Digamma 1/6 cancels, and what we get is 2 times digamma 5/6 equals square root of 3 pi plus all this, which is all negative values, minus 2 constant minus 3 ln 3 minus 4 ln 2. Divide by 2 on both sides, and this is going to be our value for digamma 5/6. Okay, next we'll take this equation, subtract this one. Digamma 5/6 cancels. What we're left with is 2 times digamma 1/6. We're going to have minus this, and then all this stuff over here. Divide 2 on both sides. And then this thing here will be our value for digamma 1/6. Okay, so finally to our original goal, we got digamma minus 1/6. We've calculated 1/6, 5/6, 2/3, 1/3, 1/2. How do we get to negative values? Well, what we can do is use this reduction formula right here. And then what's going to work here, let's see, this value z is going to be less than z plus 1. So I want z to be minus 1/6. So if you add 1 on this, what we're going to want as an input here is 5/6. So just plugging into this, what we have is digamma 5/6 equals digamma minus 1/6 plus 1 over this, which is going to be minus 6. So just solving it for the value we want digamma minus 1/6, it's going to be 6 plus digamma 5/6. But we found that value right here. It's going to be all this stuff here. Square root of 3 pi over 2 minus the constant minus 3/2 ln 3 minus 2 ln 2 and that's it. So as you can see, it's a pretty long solution and a pretty long method, but we got all these other values along the way. And wow, I made a bad mistake right here. This is definitely not natural log. Yeah, I must have been tired when I did that. Yeah, brain fog, that should be, so that's what happens when you're making videos. You kind of lose track of what you're doing sometimes. Digamma 1/2. Okay, that's it for today. Thanks everyone for watching. Have a good day.